This video is going to get you ready for your test that's tomorrow. You have a note card already made, and we practiced using it in class, so I'm just going to go through a few more problems and practice doing a few more with you. So let's review the first 6. You will see these 6 problems on your test tomorrow. And if you drew the inverse trig, I called them in class tacos. If you drew the tacos, then the answer should be really simple. So the first one they asked me about is sine inverse. And when I look at my sine picture, it goes from the bottom to the top. It goes from negative pi over 2 to positive pi over 2. So the range of sine inverse is negative pi over 2 to positive pi over 2. And then everything that looks just like sine inverse, cosecant inverse looks just like it, and so does tangent inverse. They're going to have the exact same range values. So tangent inverse is also from negative pi over 2 to positive pi over 2, and cosecant inverse is also from negative pi over 2 to positive pi over 2. So again, sine, cosecant, and tangent inverse all look the same, so they're going to have the same range values. Cosine inverse, secant inverse, and cotangent inverse also all look the same, so these 3 will have the same range values, and we'll notice they go from 0 to pi. So all 3 that are left are going from 0 to pi. So if you wrote this on your note card, this part of the test should be relatively easy. The bottom section asks me to find the exact value. When they ask you to find the exact value, they're asking you for values on the circle. And notice that when we wrote all of our inverses, we wrote them in forms of radian. So all my answers are going to be in radians. So I just picked a few. I picked a sine, I picked a cosine, and a tangent to do with you. So I'm going to do 15, 23, and 24. And I picked some different ones in class, so hopefully you have plenty of examples. So on 15, it says cosine inverse. So I look at my note card, and I notice that cosine inverse has to go from 0 to pi. So I can only look at answers in quadrant 1 and in quadrant 2. Because it's a negative cosine, that tells me to focus on quadrant 2. And in quadrant 2, I know that x is negative root 2 over 2 right here in the middle. And that right there is 3 pi over 4. So your answer is 3 pi over 4. And you're done. Let's go look at number 23. 23 is asking about sine inverse. Sine inverse goes from positive pi over 2 down to negative pi over 2. So quadrants 1 and 4. Positive root 2 over 2 is going to be in quadrant 1. It's right here in the middle. That value right there is pi over 4, so my answer actually is pi over 4. Okay, so we have 3 pi over 4. We have pi over 4 for 23. Now let's go look at 24. For 24, they want tangent inverse. So my card says I'm going to go quadrant 1 and quadrant 4 again. It's a positive root 3 over 3, so I'm going to focus in quadrant 1. At pi over 6, it equals root 3 over 3. So my answer is pi over 6. So when cosine is in quadrant 2, we write down what the angle is. When cosine is in quadrant 1, in quadrant 1 here, we wrote down what the angle is. But on my note card, I wrote something over here. I said anytime you get an answer in quadrant 4, you need to rewrite it as a negative. So let's go do one that does that. Let's go do number 20, just so you can see what that looks like. So number 20, they want sine inverse. So again, I'm thinking quadrants 1 and 4. It's a negative root 3 over 2. So now I'm going to focus down here in quadrant 4. And I know that y is equal to negative root 3 over 2 down here at the bottom. And that radian measure is 5 pi over 3. That will probably be an answer choice tomorrow, but you don't want to pick it. Because in quadrant 4, you have to use the negative answers. So instead of calling it 5 pi over 3, I'm going to call it negative pi over 3. And this is the answer that we're looking for. So if you have any problems that give you an answer in quadrant 4 that are inverse trig, you only want to pick negative answers. Okay, so that gets us all the way through number 25. Let's go look at the difference on 26 through 29. If you'll notice on these problems, we have 2 problems in one. There's an inside problem to do, and then there's an outside problem to do. I'm going to do number 26 with you and number 28 with you. So on number 26, the inside says sine inverse. So again, I'm thinking 1 and 4. It's a positive sign value, so I'm going to focus on quadrant 1. Now you're thinking to yourself, where on your circle does my y value equal 3 over 5? And hopefully you're thinking it doesn't. The minute you say it doesn't, you're going to think x, y, r. So I'm going to flip my card over and look at my trig identities. And I know that if I have sine, the y is on top and the r is on bottom. So my y is 3, my r is 5, and that happens to be one of my triples. If I have a 3 and a 5, the 4 always goes along for the ride. So now that I know my x, my y, and my r, I can go answer the question. They want to know, what is cosine? Well, cosine is always going to be the x value over the r value. My x is 4, my r is 5, so my answer is 4 over 5. All right, next one I'm going to do, number 28. Again, there's a sine inverse on the inside, so I'm thinking quadrant 1 and 4. Because it's a negative root 3 over 2, I'm thinking quadrant 4. Because it's quadrant 4, I'm reminding myself that it has to be a negative answer. I know it's negative root 3 over 2 down here at 5 pi over 3, but I'm going to call that negative pi over 3 because I'm in quadrant 4. So that's the answer to the inside. So I go rewrite my problem, tangent of negative pi over 3. So now what they want to know is, what is tangent down here at the pi over 3, the negative pi over 3? Well, tangent at positive pi over 3 is root 3. Down here, it's also going to be a root 3, but because I'm in quadrant 4, it's going to be a negative root 3. All right, so that should help you with the first page. You want to go back and check your answer key. Remember, I put the answer key on Google Classroom to make sure you got the rest of these right. I'm going to go ahead and do some on the back. So now I'm going to look at your trig identities. So if you're looking at the trig identities and you wrote these on your card, you're sitting pretty. A lot of this is just playing the matching game. So when I see sine over cosine, that's going to always equal tangent. Right here I see sine squared plus cosine squared. On my note card, I have sine squared plus cosine squared always equals 1. Number 5, it says 1 plus tangent squared, and I have a 1 plus tangent squared. 1 plus tangent squared equals secant squared. Make sure tomorrow on your test that you don't pick secant. It needs to be secant squared. Okay, so be really careful when you're doing these. Let's go look at number 6. Number 6 says 1 plus cotangent squared. 1 plus cotangent squared. So I don't want to pick cosecant. I want to pick cosecant squared. So pay attention when you're doing your test tomorrow. So look at some of them over here. This one says 1 over sine. If I look for 1 over sine, I see that that's just plain cosecant. So this one should not be a square. This is just plain cosecant. Cosine over sine is equal to cotangent. 1 over cosine is equal to secant, not secant squared, just secant. 1 over cotangent. Let's see, I see 1 over tangent is cotangent. So if I flip that, 1 over cotangent would be equal to tangent. So you just flip all these. They can go both ways. Okay, so again, if you just do a couple more of these, check them on the answer key. The answer key is on Google Classroom. Oh yeah, I told y'all to get rid of number 9. So if you didn't, make sure you do. All right, on numbers 1 through 3, on the sum and difference formulas, we're thinking to ourselves, where on the circle does cosine equal 15 degrees? And hopefully you realize that none of them say 15 degrees. So then what you're going to do is you're going to look for 2 angles on your circle that either add or subtract to 15. Well, I know on my circle in quadrant 1, this angle is 30 degrees and this angle is 45 degrees. And I know if I subtract these 2 angles, I can get 15. So these are the 2 angles I'm going to use. So right here, I'm going to write 45 minus 30. Now remember, for subtraction, order matters. It says positive 15. So the 45 has to come first. This is my A and this is my B. And I'm going to go find my cosine formula that does subtraction. So this is the cosine conga. Cosine, cosine, sine, sine. So I'm using this formula right here. I'm going to write it down. Cosine A, cosine B. And then it says to put a plus in the middle, even though that says a minus. See, the formula says a minus inside, but over here it has a plus. And then we're going to do sine A, sine B. Now everywhere there's an A, I'm going to go put in 45 degrees. And everywhere there's a B, I'm going to put in my 30 degrees. We'll continue plugging in. Okay, so now what you're going to do is you're going to go to your circle and you're going to get your cosine, your x values, and your sine, your y values, right off your circle. So when cosine is 45 degrees, right here at 45 degrees, cosine is root 2 over 2. At 30 degrees, cosine is root 3 over 2. Okay, so that's the first part. I'll bring down my plus sign. At 45 degrees, sine is root 2 over 2. At 30 degrees, sine is 1/2. Now when you're multiplying fractions, remember it's top times top, bottom times bottom. So square root of 2 times square root of 3 is square root of 6. 2 times 2 is 4. Right here, square root of 2 times 1 is square root of 2, and 2 times 2 is 4. I have a common denominator, so I know my answer is going to be over 4. Then I have square root of 6 plus square root of 2. Those are not like terms, so do not add them and write square root of 8. You just write square root of 6 plus square root of 2. You just write them side by side. So square root of 6 plus square root of 2. And you're done. And you're going to do the same thing for number 2. You're looking for two angles that either add or subtract to 75. Hopefully you can use the problem we just did and go, oh, that's 45 plus 30. And then you're going to use your sine formula. For this one right here, you're looking for two angles that add or subtract to 105. Hopefully you can figure that that would be 60 and 45. So again, these are your A's and your B's, and you just plug in to the formulas that are right here on your card. Down here at the bottom, we're working backwards. So I'm giving you the formula plugged in, and you're trying to tell me what was the original problem. So this is a sine sandwich. So it starts and ends with sine, and the cosines are in the middle. And notice in the middle, I have a plus sign. So I'm looking for a formula that ends and begins with sine. So that's one of these two, but has a plus sign in the middle. So it's going to be this one right here. So it's really a sine of A plus B. Once you've made that decision, you go label these A and B, and we plug in. So 15 plus 105 is going to give me sine of 120. 120 is located right here on my circle, and they want sine, and sine right there is equal to root 3 over 2. Okay? Now I'm going to go look at number 6A. So when you get a problem like this on the test tomorrow, you have to remember that you have an A side of the problem and a B side of the problem. And for each A and B side, you're going to have an X, a Y, and an R. You have to pay very close attention to which quadrant each part is in. So A right here, it tells me that it's going to be between pi, which is over here on the left-hand side, and 3 pi over 2, which is going to put me in quadrant 3. Quadrant 3 means my x's and my y's will both be negative. They gave me tangent. So if I'm using my note card, I know that tangent is always the y over the x. So that means my y is negative 5 and my x is negative 12. And here's one of my triples, 5, 12, and 13. Remember, r is your radius, so it's always positive. Now I'm going to go do side B. On side B, it tells me that my answers are going to be between pi over 2, which is up top, and pi, which puts me in quadrant 2, which means my x's will be negative, but my y's will be positive. My r is always positive. Cosine is the x over the r, so my x is negative 3, my r is 5, and I see another triple, 3, 4, 5. So my y is 4. Now that I know my x, y, r for both sides, I'm going to go pick the correct formula. So now I need a formula for sine of A plus B, which is right here. It's a sine sandwich, and it says sine A cosine B plus cosine A sine B. From here, I'm just going to go to each side and pull the correct letters. Every time it asks me for sine, I'm going to use the y and the r, and every time it asks me for cosine, I'm going to pull the x and the r. Okay, so it says sine A, so I come over to the A side and I grab my sine, negative 5 over 13 times cosine B, negative 3 over 5. Okay, that part's done. Bring down my plus sign. Cosine A, so I come here to the A side and I grab my cosine, negative 12 over 13 times says to go to the b side and grab my sign, 4 over 5. So if I multiply top times top, I get 15. Bottom times bottom, 65. Plus top times top is negative 48. Bottom times bottom is 65. So I have 48, take away 15, so I'm going to subtract. And I have more negatives, so it's negative 33 over 65. Okay, and you're going to do the same thing for B, C, and D. You're just going to go use the formulas that match. All right, 7, 8, and 9 all are double angles. I know they're all double angles because it says 2 theta inside all the parentheses. I'm going to focus on number 7 because I think I did number 8 in all my classes. So when you start one of these problems, one of the first things you need to do is figure out what x, y, and r are, and you got to figure out what quadrant you're in. This particular problem tells me I'm between 0 and pi over 2, which puts me in quadrant 1, which means everybody's positive. Because I have sine, I have the y over the r, so 4 and 5, and this is another triple, 4 and 5, 3 goes with it. Now that I have my x, y, and r, I can plug into my formula. First double sine, I'm going to do 2 times sine times cosine. So 2 times sine times cosine. So 2 times sine, sine is 4 over 5, and cosine is 3 over 5. Remember when I showed you all this in class, I said go ahead and put that 2 over 1 so you don't accidentally multiply the bottom and the top by 2. Only the tops are going to get multiplied by 2. So 2 times 4 is 8, and 8 times 3 is 24. 1 times 5 is 5, and 5 times 5 is 25. That one's done. Okay, this one says double angle for cosine, and I'm going to use the cosine squared minus sine squared formula. There were other formulas you could use. This is just the one that I preferred. So I'm going to write down my cosine, which is 3 over 5 squared, minus my sine, which is 4 over 5 squared. So 3 squared is 9, 5 squared is 25, minus 4 squared is 16, 5 squared is 25. I'm going to subtract the tops. 9 take away 16 is negative 7. And there's your answer, negative 7 over 25. I think I did 8 with y'all in class. That gives you 9 to try. Again, like I've said the whole time, the answers are on Google Classroom. Go check your answer key. Make sure you're doing it right. Call a friend if you have a question. All right, so let's go to the back. The back is all about solving trig equations. Notice that none of these problems have a sign inverse. So that means all these problems are on the whole circle, not a part of the circle. So we're not going to do anything like this. We're going to use the entire circle on the back. So they want my answers between 0 and 2 pi. So everything's going to be in radians. I'm just going to pick a few of these to do, and I'm going to leave the rest for you to try, because we did a few of these in class. So when we did these problems, I told you to take the word and change it to a letter. So I'm just going to choose the letter X every time. So if I said solve this for X, you would hopefully subtract 3 first. We get negative X equals negative 1. And then you divide by negative 1. And you get X equals positive 1. And then I'm going to remind myself that I'm not done. These are really sign problems. So this really says sine theta equals 1. So what that means is, where on your circle does sine, which is y, equal positive 1? Well, y equals 1 up here at pi over 2. And that's the only spot. So this one only has one answer. Okay, let's go look at number 6. On number 6, again, I'm going to change the word cosine to be an x. It's a squared, so I'm going to take 4x squared minus 3 equals 0. I'm going to add 3 to both sides to get x by itself and get 4x squared equals 3. I'm going to divide by 4 and get x squared equals 3 over 4. And now because I have a square, I have to square root it. So x equals the square root of 3 over the square root of 4. Anytime you take the square root, I told you to remember to write plus or minus. The square root of 3 just stays square root of 3. The square root of 4, though, is 2. So I want to know where on my circle, remember the whole problem was about cosine, does cosine equal positive square root of 3 over 2 and negative square root of 3 over 2? Well, cosine is square root of 3 over 2 at pi over 6. So all the over 6's are going to give me all the root 3 over 2's. And because I want the positives and the negatives, I want all of them. So this is going to have 4 answers. So at pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6, because it happened 4 times. Okay, let's go look at, number 1. So on number 1, we've got 2x equals 1. So if I said solve that for x, you would say divide by 2, and you get x equals 1/2. Remember this problem is about sine, so they want to know where on my circle does sine equal 1/2. Well, sine equals 1/2, which is your y value, at pi over 6. But I only want positive 1/2, so this time I don't want positives and negatives. So instead of having 4 answers, I'm only going to have 2. So sine is positive 1/2 at pi over 6 and at 5 pi over 6. At 7 pi over 6 and 11 pi over 6, it's negative 1/2. So I just want these two up top. So theta equals pi over 6 and 7 pi over 6. 2 answers. So number 1 had 2 answers, number 2 only had 1 answer, and number 6 had 4 answers. I'm going to go do one more with you, number 14. So you are going to have a factoring problem on the test. I'm going to change all the x's, all the cosines to x's, and then we're going to review factoring. Remember, whatever is written right here tells me what I have to have in these first 2 blanks. So what times what is x squared? X times x, and then whatever is written at the back is going to help me figure out what goes here. What can I multiply together to get a positive 1? Well, it could be 1 times 1 or negative 1 times negative 1. Because this is a positive 1, I'm going to guess 1 times 1. So we're going to guess and check. So here's my check. X times x, x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. Did I get what I wanted? Yes. So I guessed and I checked. So these are my answers. So I write x plus 1 equals 0, x plus 1 equals 0. Well, there's no reason to solve this problem twice. I'm just going to do it one time because they're the exact same problem. I'm going to subtract 1 from both sides and get x equals negative 1. I'm going to remember that I'm not done. Cosine theta equals negative 1. And then I'm going to say where on my circle does x equal negative 1? Well, it equals negative 1 right over here. So theta equals pi. Okay, so again, go work some more problems. Check the Google Classroom for the answer key, and call a friend. Ask each other for help. Notice I did mark out a couple of problems. Mark out number 12, mark out number 15. I hope you study, and I hope you do well on your test tomorrow. Good luck.